So this is my SDL for week 4, which is based on selectivity and resolution. So basically, I'm just going to give a brief overview of selectivity. Um, as you can see in this picture, we have blue and red components moving through the stationary phase, where the stationary phase are the yellow spheres. And they're moving at different speeds in the stationary phase. As you can see, there are different tensions of the two components with the stationary phase. This causes elution at the end of the column to be at different times, and hence their separation. You can see the red molecules eluting first and then the blue molecules afterwards. And when all the molecules are moving through the mobile phase, they go at the same speed. Basically, this is the different degrees of retention in the stationary phase, and that's the essence of selectivity. Okay, now the first learning objective, which was to identify parameters influencing selectivity. The first parameter will be organic solvent, so changing to a different solvent, for example, methanol to acetonitrile in reverse phase HPL, will definitely alter the selectivity. Another example would be mobile phase pH, so that can alter the degree of ionization of some analytes, affecting their hydrophobicity. The third parameter that could affect selectivity would be solvent strength and adjectives. So that can be adjusted to affect selectivity as well as the retention capacity factor. Another example would be stationary phase, one of the most popular ways to alter the selectivity of a separation. And finally, temperature. That can have a effect with certain analytes in reverse phase and chiral HPLC. The second learning objective asks us to establish the relationship between selectivity and resolution. So as you can see in this equation right here, selectivity is a factor that affects resolution, another factor being efficiency and also retention. So changing selectivity can have a dramatic effect on the chromatographic resolution. Well, selectivity is actually relatively simple to alter, with some mobile phase constituents and pH being the most popular methods of adjustment. And in our recent chromatograms, 6 peaks were seen despite changing the mobile phase composition. So maybe by altering the pH, temperature, or stationary phase, we may get better resolution obtained and 7 peaks might be observed. Uh, Thank you for listening.